You know, when an AI looks at a picture, what is it actually seeing? It's a good question. For years, the world of computer vision has been, well, pretty fragmented. You needed different AI models for different ways of seeing. But what if one single model could do it all? Today, that's what we're talking about. We're going to dive into this amazing paper on an architecture called Mask2Former, which promises to do exactly that.
All right, take a look at this image. It's a busy street, right? But this isn't how we see it. It's how an AI sees it. See all those colors? Each one is a different object or area that the AI has picked out. This whole process is called image segmentation. And for, forever, the big question, the real holy grail in this field, has been, can we build just one smart AI that can understand and segment any image we throw at it for any task?
Okay, so let's get into it. To really get why one model to rule them all is such a massive deal, you first have to understand that image segmentation isn't just one thing. Nope. It's more like a family of 3 different but kind of related jobs. So at its very core, segmentation is just about grouping pixels. That's it. Instead of a jumble of random dots, the AI learns to lump them together based on what they actually are. This is like the absolute foundation of how a machine starts to make sense of the world it sees.
First up, we've got something called semantic segmentation. The easiest way to think about this is like painting by numbers. The AI gives every single pixel a category label. So all the car pixels get labeled car, all the person pixels get labeled person. It's awesome for knowing what's in the picture, but it has one big limitation. It doesn't tell you if there's 1 car or 10 cars. It's just a big blob of car. And that's where the second task, instance segmentation, comes into play. This is the next level up. It doesn't just see a blob of car. It knows there's this specific car right here and that specific car over there. It actually identifies and separates out every single individual object or instance. And you can imagine this is super important for stuff like counting objects or tracking them as they move.
And finally, we get to panoptic segmentation. Now, this is the whole shebang, the ultimate goal. It's basically the best of both worlds. It gives a category label to every single pixel, just like semantic segmentation, and it knows which individual object each pixel belongs to, just like instance segmentation. It's the most complete, most detailed way an AI can understand a picture. Period.
So, okay, you have these 3 different tasks. For the longest time, that meant you needed 3 different, super specialized AI models to do the work, one for each. And you can probably see why that led researchers to chase after this universal dream.
The best way to think about it is like this. The old way is like having a big toolbox full of individual tools. You've got a hammer, it's great for nails. You've got a wrench, perfect for bolts. But the problem is you have to design and build and fine-tune each one of those tools separately. The dream? It's to have one of those awesome multi-tools. You know, a single, powerful device that can handle all 3 jobs without breaking a sweat.
And look, this isn't just some abstract academic idea. The actual researchers behind Mask2Former said it best. There's a massive real-world cost to doing things this fragmented way. All that duplicated work, all that wasted effort, it really, really adds up.
So the obvious question is, why didn't this happen sooner? If a multi-tool is so much better, why haven't they taken over already? Well, here's the problem in a nutshell. Past attempts at these universal models, they were flexible, but they just couldn't keep up with the specialists. Just look at the chart. On a really tough task like instance segmentation, the best universal model out there was lagging way behind the specialized one. It was a classic jack-of-all-trades, master-of-none situation.
That is, until now. It's time to introduce the hero of our story, the thing that finally cracked the code, Mask2Former.
And here's the absolute kicker. Mask2Former isn't just a better multi-tool. It's a multi-tool that's now better than the best individual hammer and the best individual wrench. This is the first time ever that a single universal architecture hasn't just caught up. It's actually setting new world records across all 3 tasks.
So you're probably wondering, how on earth did they pull this off? What's the secret sauce here? Well, it all comes down to a really clever innovation called masked attention.
This is such a great way to visualize it. Think of how older models work. Their attention mechanism is like a giant floodlight. To figure out what one single object is, they blast the whole image with light, wasting tons of computational energy on the background and everything else. But masked attention? That's like a precision spotlight. It learns to focus its attention only on the tiny area where it thinks an object actually is. And that one simple idea?
It changes everything. By just ignoring all that useless background noise and focusing only on what matters, the model learns way, way faster. We call that faster convergence. And not only is it faster, it gets much better results. It's just smarter and more efficient all around.
But wait, it gets even better. It's not just more accurate. Mask2Former is also way, way more efficient. How much, you ask? A lot more. We're talking 3 times more efficient.
So what does that actually mean in the real world? Well, because of a new training strategy, it cuts the amount of computer memory it needs by a factor of 3. Now that might not sound exciting, but trust me, it is a huge deal. It means you don't need a massive supercomputer to run this thing anymore. It basically democratizes this incredible technology, putting it in the hands of way more researchers and developers everywhere. All right, so the theory is solid, the ideas are clever, but what about the proof? Does the data actually back this all up? Let's check out the results and see how Mask2Former really stacks up against the champs.
Okay, first up, panoptic segmentation. That's the do-it-all task, remember? The score they use here is called panoptic quality, or PQ. It basically measures how well the AI labels stuff and separates it. The old record was a 54.6. Mask2Former comes in and just smashes it with a 57.8. That's not a small improvement, that's a giant leap.
But now for the real test, instance segmentation. This was the one where the universal models always fell short. The score here is called average precision, and it's basically the gold standard for finding and outlining every single object. The top specialized model had a score of 49.5. So where did Mask2Former land? 50.1. It didn't just close the gap, it actually beat the specialist at its own game. Incredible.
And to complete the hat trick, let's look at semantic segmentation. It's the exact same story. The score here, MIOU, just measures how well the AI's predictions line up with reality. The best specialist was at 57.0. Mask2Former, a new record of 57.7. The conclusion here is just impossible to ignore. One single model is now the undisputed king of all 3 segmentation tasks.
So, what does all this mean for the future of computer vision? Because let's be clear, this is way more than just getting a new high score in a competition.
Let's just break down the impact. First, it's going to save a ton of time and money in research, because now everyone can focus on improving one single architecture. Second, like we talked about, it makes this amazing tech accessible to way more people, not just the big labs. And third, it just sets a totally new bar for what's possible. It really feels like the age of needing all these different specialized models could be coming to an end. That universal dream? It's pretty much here.
At the end of the day, this breakthrough is more than just code and numbers. It's a powerful new lens for understanding the world around us, a lens that can see things with a clarity we've never had before. And that leaves us with a pretty big question to think about. When we have an AI that can segment literally anything, what will we choose to see?